Hey there, Guru. This is going to be looking into part 2 of 11E Leslie Matrices. It's highly recommended that you look into how the first part of Leslie Matrices work. We did this in class, but if you weren't in class, you can go ahead and read the examples prior to example 11 from 11E. All right, let's get straight into this. So what we'll be looking into is how Leslie matrices, we can look into the future and make some, not only predictions within the future, but make some number generalizations. That's the whole premise of these next couple of examples. So let's have a look at this one here. Consider the following Leslie matrix and initial population S of 0. So we have 3 age groups here, starting one with 1,000 and then the other two in 0. We have a Leslie matrix that showcases birth rates and survival rates. What we're going to do is we're going to be looking into what S5, S10, and S50 are going to look like. Now, we've already seen the formula of how to find any number that's greater without a recursion of some sort. So just to recap, to get S5, this is going to be whatever your Leslie matrix is to the power of that position, so to the power 5. And we always multiply this with the initial matrix. When you go ahead and do this for the first one, you'll end up getting 1,250 and 62.5. Now again, we can just do this for S10 and S50. You can go ahead and do this in your calculator. I'll write the answer right now. So I've gone ahead and given S10 and S50 using the continuing formula. Now a few things to mention. These have been rounded to 2 decimal places. It doesn't specify that, but that's just your general rule of thumb. The other thing you have to take notice is that when you write your solutions, just make sure that the numbers are in line, especially when you're dealing with decimal places. You don't want to have this like push to the side or have this inconsistent decimal rounding. So you want to make sure that it's consistent. That way we can see that, with putting commas here does help. You can see that that first row for the starting age group is much higher than the other one. If you don't show that alignment, for the everyday reader, they might think that that second number might be 5 million, not 582,000. So just something to be wary of. Now, there's a little note afterwards that says that you are going to pre-multiply all of these state matrices, also S5, S10, and S50, by this matrix, row matrix of 1, 1, 1. And that's going to help us calculate the total populations of all the ages into one whole number. So what this means, if I chuck a 111 in front of this and do that 111 times that, remember the 111 attaches to the 3 numbers, and you're just going to get this finalized number. So the S5 total, S5 total, this is pre-multiplied by 111. Obviously you can do this manually, but to have your calculator do this process, especially if you can store these ones, just makes it easier. So we've got S5 total to be that, S10 total to be 3250, and the last total for S50 is going to equal to 360. This is a big number, 3604272.20. Now the reason why excuse me, we can make predictions about this being a big number. It's because of these birth rates. We're showcasing birth rates of 4, which is quite exponential. Even though the survival rates are small, the birth rates being 4 outweigh that. And so when you look into this in 50 time frames, you're going to get a large number. Excuse me, and got down with the sickness. Yikes. For question B, you're going to determine S25 and S26. And then you're going to divide each age group population for S26 by the corresponding age group population S25. And you're going to showcase that there's this ratio of 1.1915. What this is essentially saying is, if I get my S25 and S26 with a little bit of editing, calculated S25 and S26, and what we're going to do is we're going to grab, and we're just going to like look specifically at an age group, so the first one, And we're going to look at S26s and S25s. And what we're going to do is let's just call this A of 25 and A of 26. A just meaning that we're talking about that particular age group, A. The other ones I'll call B and C. And what we're going to do is we're going to take A26 and divide this by A25. So we're going to compare this age group to the other one as a ratio. And what we'll find is when we do this to the other ones, compare B26 to B25 and C26 to C25, C26 to C25, these should be all approximately equal to 1.1915. So what that previous statement was saying is S26 is approximately equal to 1.1915 of S25. It's risen by 1.1915 or 119.15%. So whenever you tackle that type of question, especially in your SAC, you always take whatever time frame they're thinking about. If they're looking into like the future, you take a higher group like S100 and S101, and you compare each age group. Tedious, yes, but that's a manual process, and you should come up with a ratio. Now, the last example for all the matrices in 11E, we've got this lazy matrix here. Now, what I wanted to showcase is we're not doing C per se. I just want to care about A and B. You're going to find S10, S14, and S15. Pretty simple, using your formula. The question B is the one I really want to concentrate on. It's saying that the rate increase, try that again. The rate increase of the population is a constant, and each of these age group populations increase in the same way. Find the rate by comparing S14 and S15. So you would have already completed this with the example, but you're going to find S14 and S15 with a bit of editing. I'll do that. Do the comparison, and we'll see what number that we get. All right, so we've got S14 and S15. When you go ahead and compare the first age group to the second age group, you always do the biggest, or the next age group divided by the previous one. So again, it's 15 divided by A14. Now these are all approximates. You're not always going to get exact numbers because we're dealing with quite interesting decimal numbers. So if they're approximate or they're close to each other, that's completely fine. Now this growth rate here is 1.2. So you would just say the growth rate from S10 to S11 is 1.2. Now I did mention something just prior before that if you're going to look for this particular ratio when you're looking right into the future, it's assumed that that population group will hit a stabilization. Not always. In transition matrices you do, but with lazy matrix it's a little bit different because you're always going to get this you're always going to get a birth rate and a survival rate, which will always fluctuate the answers depending on what type of numbers you get. But with that said, if you do get some type of stabilization, your growth rate will be consistent. In that case, it will be 1 because you're just going to divide one number by another number and it will be exactly the same. Very rare for it to happen, but I thought I'd just mention it. All right. There's questions for part 2 of 11E, 7 and 9. This will be the last exercise for the matrix topic. Best of luck if you watch this for your SAC. I'll see you in maybe whatever next video I have to make. Hopefully I'm not sick.